Hello. Am I audible? Hello. Can you hear me? Anyone?
Yes, sir.
Yes, sir.
Yes. So, good evening to all of you. Hi,
Good
Kiran.
evening, sir.
Is there any other session is going on or don't know the?
Sir, your voice is low.
Now, is it fine or is it? Can you hear me properly now?
Yes, sir.
Fine. Okay, great. Okay, so I'm going to share my screen. Okay. So today's session is about week 10 solve with us. So I'm hoping you are aware about how to join this peer day. If you know, let me repeat the procedure. What you do, just simply open your browser in your phone or desktop, whatever you are currently. So just write down joinpd.com. After that, you have to enter this code B G C A V Y. Okay. So join this fast and we'll start this. We'll try to solve the some question which is related to week 10 content.
Sir, hello, sir.
Please.
Sir, will the deadline for week 10 extend?
No.
For CT, it is extended for. Uh,
Is it? For how many days?
Sorry,
For how many days? When is the due date for week 10?
tomorrow.
No, okay. For tomorrow, it's I know. You told me like for city it has been extended, right? So in city, when
Yeah,
is the due date?
for CT, it is 10th.
Is it for
Uh,
week 10 or
uh,
week 11? Please check carefully. As of my knowledge, I think due 10th April is the due date for week 11 and 17th is for week 12. Can you cross check again?
so, could you please repeat? Your voice is breaking.
Okay, so I was saying, just check, as per my knowledge, on the 10th April, right? 10th April is the due date for week 11 assignments,
Yeah,
correct? So this is the week 10. Okay, in CT week, sorry, 10th is the due date for week 10, correct? That is
yeah.
something you are saying. And
Yeah.
due date for week 11?
For week 11, I think the same.
17th, sir.
week
17th.
11 is 17th.
Huh?
And week 12?
Yes, sir.
Week 12, there are no assignments, sir.
Okay, in CT there is no week 12, right?
I mean, in week 12, only tutorials are there, no
Okay,
assignments.
okay, fine, fine, fine. Okay, that's why they are okay. Because in the statistics, right? Maybe you have seen in maths one. In maths one, due date is for week 10 is tomorrow, right?
Yeah, in max
Yeah,
also.
correct, correct. Because see, we have you will get assignments in week 12 also. So for statistics one, for week 10 due date is tomorrow, and 10th April will be the week date for week due date for week 11, and 17th April will be the due date for week 12. Okay.
Hmm.
Yeah.
So week 12 will be for revision or
No,
new
no, there will
content
be
will be
content.
discussed.
Yeah, there will be content in stats one, and there will be questions in your end term also from week 12. Okay. So we'll release by tomorrow. Week 12 will release in stats one.
Sir,
So week
why
12 is binomials or
So week 11 is the binomial. By all the discrete distribution covers under the week 11. In week 12, we will deal with the continuous distribution. Okay.
sir, sir, for week 9 only, like the reason given for not extending the deadline was you had to calculate the eligibility criteria for it. But why the extend the week 10, 11 graded
Sorry,
assignment
why?
deadline? Sir, the usually after quiz 2 there will be an extension for the deadline, but this time we were not given any extension because the reason we were given the
Mm-hmm.
reason that
Mm-hmm.
for finding the eligibility criteria for the end term,
Mm-hmm.
we need to have the first 9 weeks assignment score, and then
Mm-hmm.
based on that the calculation will be done. That was the reason for not giving extension for week 9. But why not for week 10, sir?
It's the rule decided by the team, right? It's not for us. So, like,
sir,
it's I mean,
sir, you
actually,
are also instructor, right? You are instructor or faculty?
so I'm instructor for statistics one and statistics two. Okay. So, thing is, those all eligibility and all, right? So, those all things are decided by the other team also. Okay. It's approval from the professors and all. So, since see, suppose thing is that suppose we are taking the eligibility criteria, for example, from week 11 and 12, right? After week 11, week 12, there is very few days to, I mean, there is very few days for the your end term exam, right? So there are some lots of backend procedure they have to do. They have to decide the criteria. They have to decide the some centers, hall ticket, and everything, right? Who is going to give end term exam or not, like that. So there are lots of backend procedure is going on. So in stats, week 12 will be there. Okay. Most probably by tomorrow we will release the week 12 content. Fine. Is that all right? So should we start?
Yes.
Okay.
Yes, sir.
Yeah. Fine. Okay. So this is for week 10. As per the previous weeks also, you can see like I will give some time limit as per the level of the question, and we'll try to solve the some questions related to week 10 content. Okay. And you know how to enter the answer and all. The top below corner will be not top, actually below right corner there will be one green face where you have to sorry, uh, answer. Submission will be automatic. Fine. So yeah, so this is the very first question. This question says, in a box of numbered balls are numbered 1 through 1 2 3 and 4, such that probability of drawing a ball is proportional to the number on the ball. Okay, what do you mean by this? I mean, suppose there is a ball, on that ball, 1 is written there, right? And probability for drawing a ball is proportional to the number on the ball. Then 2 is there, then proportional to the number on the ball. Then 3 is there, then probability is a proportional to the number on. What do you mean by I mean, are you getting the meaning of this statement? Yes, no?
Sir, total number of outcomes will be the same, right? So proportional means uh, the probability depends on the number on the ball.
Probability is proportional to the number on the ball. What do you mean by that? Are you getting meaning of this or not? Anyone?
No, sir.
So, that is the probability for a ball is equal to the number on the ball divided by total number of balls.
No, that is not. See, here proportional to the number on the ball. Suppose I'm saying probability. Okay, so for one, suppose I'm saying, let's say it's x. Probability is x, right? So proportional to the number on the ball. So when you will draw the ball with numbered with 2, right? So then for that probability will be 2x. Then 3x. Then for ball with number 4, probability will be 4x. Got it? Okay. So based on this information, just try to solve this question. I'm going to give you 3 minutes. You to calculate the expectation of a number on the ball. Yeah, fine. Any one of you, do you need another time limit? Yes, no.
No, sir.
Fine. Okay, so rather than answering on G chat, sorry, this Zoom chat.
Sir,
Hmm, hmm,
I got disconnected. Can you give some more time for 30 seconds?
okay, fine. Let me give you 1 minute. So what you can do, just join this peer deck. So for that, just enter joinpd.com on your browser. After that, you have to enter this top right corner code, which you can see on my screen. Then you will be able to input the answer from your end, and I will get the submissions from your end. Okay. So for this top right, I mean, you can see this code is on my top on the screen of top right corner. So Okay, so just write joinpd.com on your browser. Yeah, Kiran has given you the link, and after that you have to enter this code, which you can see on this top right corner screen. Okay, fine. Okay, so let's me see the responses from your end, which you entered 3, 2.5, 7.53. Okay, let's see. There are some varieties in the. Okay, let's see this all. So you can see the PMF of. Okay, so first of all, to find the expectation, right? What we need, expectation is defined as how? So expectation. One second. Just give me a second. I will open a PDF where we will take that. Now, so how expectation of a random variable is defined as expectation of any random variable defined as the summation of x into p of x, right? Yes or no? Values of x into corresponding probabilities, right? Means weight associated with for each values of x. Now, in this case, if you see, we don't know the PMF, but to calculate the expectation, we need the PMF. So first of all, we let's define the x, or x is something you can say number of the ball. Some okay. So x is how much? What are the values x will take? 1, 2, 3, and 4. Correct? Right? These are the possible values your x will take. What is the probability? If you see in the question itself, it is clearly mentioned probability of drawing a ball is proportional to the number on the ball, right? So we have to choose. So you can see for one it will be k. For two, it's a proportional to the number on the ball. So for two it will be 2k. For three it will be 3k. For four it will be 4k, right? Now so the total number we know, first of all, here we can see we don't know the value of k, right? So sum of total of we know summation of all the probabilities is equal to 1, correct? So we'll add all these probabilities. So we'll get 10k equal to 1, which is k is equal to zero point 0.1. Now we have a correct PMF, right? For 1.1, for 2.2, for 3.3, for 4.4. So what is the expectation of x? Summation of x into px. So expectation of x will be 1 into zero point 0.1 plus 2 into zero point 0.2 plus 3 into zero point 0.3 plus 4 into zero point 0.4, which is nothing but 3. Okay. So is this clear? This was a very simple question. Is this clear or any doubt? Is this all right for everyone?
Yes, sir.
Yeah. Good. So let's move to the next question. Now here, so in the very first question, what was the scene? We are drawing a single ball, and then we are doing the we are calculating the expectation. Now, if you see the question, it says if a group of three balls is drawn at random with replacement from the box, then what is the expectation of sum of the numbers on the balls drawn? So what we have to do, we can find. Okay, so here okay, anyone can tell me what is the which property you have to use here? So you have calculated for a single ball, right? Yes, no, anything?
Yes, sir, we calculated for single ball. So should we keep adding 3 plus 3 plus 3 will get answer?
Yeah, so which property you are using?
E of x plus y plus z equal to E of x plus E of y plus E of z.
Correct, correct, correct. So it's a mention with replacement. So with replacement means probability will not get changed for a second ball, right? I mean, probability means I'm here. Sorry, it's not probability. So total number of balls will not get changed, correct? So it will be the same scenario,
Okay, sir.
right? Okay, so do you need extra time limit?
No, sir.
Okay. Should we okay. Uh, in the upcoming slide, there is question related to without replacement. So if you'll do without replacement, right? So probability will get changed. Okay. Let me explain you. Okay, let me first see the responses from your end. And 9, someone has entered 4, 12, some random answers also. Okay. So here, if you see, it is asking about three balls, right? So this was the single ball, right? This one for the single ball, correct? So suppose I can simply say, suppose I'm denoting x1, for example, or let's say x1. This is the let's say it will denote the number on the first ball, correct? If this is the case, right? So if okay, then if x2 will denote the number on the second ball, can I say or not? Then x3 will denote the number on the third ball, right? So if you do, I'm saying with replacement. So with replacement, if you draw a single ball, right? There were supposed total four ball, for example. If you draw a single ball, what is the probability to draw a ball? Yes,
1
no.
by 4.
How?
It is proportional to,
It's a
so it will be
proportional
x
term.
by 10.
Okay,
X by 10, sir.
x by 10. Or let's try to understand with 1 by 4 itself. Just assume what I'm trying to explain. Just see. Okay, let's just assume there are equal probability. For example, okay. Then for a single ball, it will be 1 by 4, correct? If you want to draw next ball, then
1 by, no, 1 by 3.
1 by 3, correct?
1.
So basically, you can see the total number will get changed, right? So I cannot apply the direct this property itself, correct? So okay, what I mean here. So if I'm doing for this x1, right? Anyway, I should have all the balls, correct? For this case, yes or no?
Yes, sir.
Right? And we know expectation for a single when I'm drawing a single ball. Okay. Okay. If we are doing with replacement, then if you draw the second ball again, you will be having all the balls, correct?
Yes, sir.
If you will draw the third ball, if you are I'm doing with replacement again, you will be having all the balls,
Correct, sir.
correct? So what we are doing, we know for a single when we are you can see the first question itself. First sub part, when we were drawing a single ball from the box, then the what was the expectation? Expectation was 3, right? Correct.
Yes, sir.
So that means I can say expectation for xi or x1 will be 3. Okay,
Yes, sir.
what x1 denote? X1 means I'm going to draw a ball. It will again denote 1, 2, 3, 4, and probability will be zero point 0.1, zero point 0.2, zero point 0.3, zero point 4. Correct? Yes or no? So x1 means what? You are drawing a ball. Yes, no? Are you
Yes,
getting
sir.
this? Are you getting this? I'm going to do with replacement. This means again I will be having four ball. So x2 will take again 1, 2, 3, 4, and when you will draw next ball, it will be 0.1, 0.2, 0.3, something 0.4. So expectation for each xi is the 3, right? Xi means I will be 3. I will be 1, 2, 3, correct? So we need for all the three balls, I mean expectation of the expectation of the sum of the numbers on all the three balls, which I can denote. Let's say I'm saying, uh, I'm here treating as xi. Let's say y. Y is nothing but x1 plus x2 plus x3. Can I say? So this will represent the sum of the numbers on the balls drawn.
In what are is this the only context in which we are going to perform the summation of this exercise,
Hmm.
or are there also some different contexts in which we are required to do the similar operation?
No. Can you repeat what you're trying to say? I
I'm
didn't.
saying the same the thing that we did now for y equals to x1 plus x2 plus x3.
Hmm.
And this thing we considered one thing we considered that the probabilities remain same.
Hmm.
And another thing
Yeah.
is then that is x also remains same. In that case, in these two conditions, we can perform this x1 plus x2 plus x3 to get the expectations. Yeah.
Correct. 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 So because anyway,
Is
see,
there any scenario? Is there any another scenario beside this in which we are required to do the same?
no, it will depend. See, if you, it will depend on the objective of the question, right? Objective, right? Say, see here, what is our interest? Our interest is to know what is the expectation of the sum of the numbers on the three balls, correct?
Yes, sir.
Okay. What x1 will denote numbers on the first ball,
First ball. Yeah.
x2 will denote numbers on the
Second ball.
x3 will denote numbers on the
Third ball.
correct. So we need some expectation of the sum of the numbers on these on all the balls drawn, right? All these three balls.
Mm.
So can I
Yeah.
add this, correct?
Mm. Yeah.
It can, see, it will depend on the objective of the question. Suppose you are interested to find the 2 times of x1 plus x2, correct?
Mm.
Then you can
Okay.
apply. I mean, it will depend on the what is your objective of the question, right? Here I'm just simply
Uh,
interested in the sum of the numbers on the balls drawn, correct? I'm going to add
okay.
this all things, correct? So we have to find the expectation of these things, right? Expectation of y. And we know I can simply, that means expectation of x1 plus expectation of x2 plus, I mean, this is something I can do, right? And by the
Yeah.
properties of expectation, we know I can write this one or not, right? Irrespective of the each exercise, right? So, and this is the for what? Expectation of a, when you are drawing a single ball, right? If you draw first ball, right, then what is the expectation of x? We have calculated in the previous question.
It's 3, sir.
It was 3, right? Okay. Then if you draw the second ball, then it will be 3, then 3. So it's a 9. Is it
Sir,
clear?
how will it change if it is without replacement, sir? How will it change?
Yeah, there is a question. I will show you.
Okay.
Okay. So actually, see, I think I don't know whether you have seen the week 11 content or not, right? If you see the binomial, right? Binomial distribution. So in binomial distribution, we are doing the things with replacement. Okay, we are not doing the without replacement. For example, okay, have you heard about binomial?
We have heard about it, but
Okay,
we have
maybe
not
you
seen the
you
week
don't have.
11.
Okay, okay, okay. Once you will see, right, we'll discuss more on it. So in without replace, sorry, with replace, what are the things? Probability will not get changed for next trials. So there is something called with the same scenario hypergeometric distribution. Okay, in hypergeometric distribution, if we will doing the without replacement, right? So probability will get changed. What I mean, suppose, for let me take an example. Suppose there is a box. In that box, there are 4 white ball and 3 black ball. Okay, just assume if I'm doing a without replacement. Okay, so first of all, tell me what is the probability of drawing a white ball?
4 by 7.
What is the probability for drawing a black ball?
3 by 7.
Now, if you are doing a without replacement, now tell me what is the case now? It will be 3 white and 3 black,
Yes, sir.
and 4 white, 2 black.
Yes, sir.
What will the probability now to draw a white ball?
3 by 6.
3 by 6.
And what is the probability to draw a black ball?
2 by 6.
2 by 6.
Now you are observing this probability will get changed.
Yes, sir. But in the this I can understand, but in the expectation problem, how do we do? Like,
Okay, see, okay, why we are doing? Because we are observing for each x1, right? Each exercise.
Okay, sir.
For example, see, if you see, if you are doing the without replace first of all, then total number will get changed or not? Correct. Total number of balls will affect.
Yes, sir.
Correct. If total number of ball will affect, then we can't directly add all these things, right? Then we have to calculate the separately for x1. See, probability will get changed anyhow. So, okay, what I'm meaning, suppose this
So if
probability
we
will
do the
get changed.
same problem without replacement, the balls numbered 1, 2, 3, 4, that
Hmm.
question, same question without replacement, how will we do, sir?
Okay, tell me what will the probability then? Each xi is taking 1, 2, 3, 4, right? Probability is 1 by
0,
10,
2 by
2
10,
by 10,
3 by
3 by 10, and
4 by
4
10.
by 10, right? So that means we are drawing a ball with number 1, right?
Okay,
So,
sir.
and this is ball with number 2, ball with number 3, ball with number 4. Correct?
Correct. Yes,
Now,
sir.
if you are doing with replacement, so here in the question it is clear. It doesn't mean we are not focusing on the numbers. Okay, let me do. Okay, tell me if I'm drawing a single ball, then
Then it is 3. I mean, expected number will be 3.
okay, expectation is the 3. I'm talking about the probability.
Probability of what, sir?
Probability of drawing a single ball or ball is okay. Here we have to mention. Suppose I'm saying x is you are drawing a ball with number 1. Okay,
Then it is 1 by 10.
1 by 10 with number 2, 2 by
2 by
10,
10.
3
Yes.
by 10, and
And
4 by
4.
10. Right now,
Okay.
so okay, so we got expectation as for a single ball.
Yes, sir. That was 3.
That was
3.
3, right? Now, if you want to draw second ball, then and see without replacement means suppose it will get changed. Total number will get changed, right?
Yes, sir. So how will we calculate the new
Then
probability,
see,
sir?
then it will affect the proportionality constant also.
I don't understand, sir. So if we
Hmm.
are, so first round we have the expectation is 3. If
Hmm.
we are picking one more ball,
Hmm.
then what will be the expectation of the number? So should we
Fine.
reduce the 3 ball at all? Like we should remove the ball 3 from the
But
set?
we have to take care one more scenario. Which ball we are reducing?
That's what, sir. So since the
Correct.
expectation is 3 in the first
Ah,
round, so maybe the 3 will be eliminated. Then we'll have first number 1, 2, and fourth ball. Will that be the case, sir? Or like how to do?
no, no. Expectation doesn't mean it's a third ball, right?
No, the
It's
expected number which is drawn is 3. So we are expecting third ball will be taken out. That is what expectation is actually.
correct, 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 correct.
So,
So yeah, that's good thing actually.
or let us take equal probability, sir. Let's take 1, 2, 3, 4. All have equal probability. Then how do we do, sir?
Okay, see, if we have 4 ball, okay,
Okay.
suppose okay, so I think that will be little bit different. For example, I have 4 balls, correct?
Okay, sir.
Okay, so then x it will depend on the x also, right? How x is defined. Suppose if it is a 4 ball, right, and I'm going to draw some
Let it
let's
be.
say
Let all the balls take equal probability, sir. Then we will. Then can we try to do it?
okay,
It
how will you
isn't
define your x here?
the number which
Number
is
on
printed
the
on the
ball or
ball.
number of the ball?
Number on the ball.
Number on the ball. So you are specifying 1, 2, 3, and 4,
4.
right?
Yes,
So
sir.
1, 2, 3, and 4.
4
And
each have equal probability. 1 by 4, 1 by 4, 1 by 4.
okay, fine. Right?
Okay, sir.
Now tell me, if we'll do so what will the expectation? It will be
It
something
will be
5
1
by
plus 2
2,
plus 3 plus 4
2.5.
plus 2 plus 3.
4,
10 by 4,
7, 2,
2.5.
9,
2.5.
2.5,
5.
right? 2.5 for this case, right? If
Yes, sir.
you'll do without replacement, right? So this is for the suppose you have drawn 1 ball. If you I
Yes.
will do if let's say x2, we are
Okay.
drawing without replacement. Now tell me, but we have to be clear with one statement also. Which
Uh,
number of the ball we have drawn.
Okay, let us take upper bound. Let's take 3 is removed. So we'll have first ball, second ball, fourth ball. Now each probability will be 1 by 3.
Correct.
So, but cannot we go like the same that probability, how you draw the probability tree
Mm-hmm.
in a like slightly upside? That when you have a white ball and when you had a black,
This one, correct?
yeah. Cannot
Mm-hmm.
we divide the same? Cannot we use the
We
same approach? Like,
we
let us
No,
we
put
can, yeah,
that will
we can
no
sim
that will give you
we,
the probability, but how do we find expectation? For that, we need this formula, right?
so okay, it's not about, see, don't generalize it. See, we have sum of all the exercise, so because the total numbers will not get changed, right?
Hmm.
Okay, that's why we
Yes.
have generalized. So suppose you have these four balls, okay, for example, so it will be like this, three, four,
No,
okay.
no,
Suppose,
sir. No. The same question. After taking three balls,
mm-hmm,
what is the sum of the numbers? Like the same question that we had in the slide.
mm-hmm,
So first, let us see in the X1. So it is the sum of, if you take three balls, what is the expected number when we add the numbers on all three balls? Same question when we do without replacement. If it is 2.5 in the first round, then
correct.
let us round it up. It is okay, sir. Let's take it as three. Then how do we proceed? So the next
Anyway,
round will
let's
have,
2.5 or 3 itself, right?
let's take it
If
as three, sir. That's okay. So
if
the
I'm
next round
doing
will have,
x2, okay, one second, let me think. If you are doing x2, that means you
sir,
have to draw. Hmm,
in this context, I have one single like if we are considering that each ball has the same probability, then the first event it's 1/4 probability with associated with each ball. But
correct,
hmm,
after we have drawn a ball, the probably if they are still equally probable, then this probability becomes 1/3 for each ball.
correct,
Then
correct,
exactly.
correct.
again it
That's what,
becomes 1/2.
yes, that's what I
Yeah.
wanted to do it actually. That's what I wanted to, sir,
So
to
if
do.
you see, suppose, but one thing I'm getting confusion here. I mean, but we have to be clear with which ball we have like
Let us round up
drawn.
and take, sir. Let
Okay.
us take it as round up. So
Okay,
the
for
question
example,
is just,
suppose third ball we have drawn, right? Then
huh,
it will be one, two, three.
and
I mean,
no,
mainly
one,
we
two,
have,
and four. First ball,
sorry.
second ball, and the fourth ball will be there.
Anyway. I mean, thing is
Each
that
probability will be.
we suppose we have three balls left, for example.
Huh,
Okay.
yes, sir.
Then
Okay.
it will be one by
By
three,
three,
one
one
by
by three,
three,
one
one
by
by
three.
three. Correct.
So now the expectation will be
Four, two,
seven
six,
by
seven, 7/3, right?
seven by
Some
three. Will be approximately 2 point something.
2 point something. Okay.
So
Again,
let us round it down. Let's take it as number two, right?
mm-hmm.
Because it is close to two, not close to four. So let's remove second ball. So then we'll have first ball and the fourth ball.
First ball. Again, it will be half half. Then it will be at the end 1 into 1.
2.5. So by adding at least, like I'm trying to find, like, if we get without replacement, how do we
So,
proceed to this?
can we see this problem in this context? Like when we are calculating expectation, if you guys remember, then there was a question when we were transforming x, when x1 values were given as -1, 0, and 1,
Hmm.
and we were doing squaring it, and we
Hmm.
were uh, clubbing this thing in the values of 0 and 1 when we were squaring the expectation value
Hmm.
in the similar context, like when we are like when we have first four, like there was a simple one more example, similar example in the lectures.
Hmm.
If you remember that when we have like a policy uh, person, like a companies need to pay a person when he expires. Yeah, we were given associated probabilities. If a person one dies or a person two dies. In that case, when we calculated the expectation of at least one is alive, we
Hmm.
saw that either the first one is alive or either the second one is alive. Yeah. So in the similar context, if we extend the same idea here, that is, we can choose like three objects from the four in like four choose three ways. Yeah. So it's
Okay. Okay.
if it's
Understood.
equally
Understood.
probable, then it's four choose three times this thing. The
So you are
means
saying I have some four balls, right? Then
yeah.
for expectation of to draw single ball, right?
Yeah,
Okay.
expectation of single ball is like 1/4 each. That is 10
I
by
mean
4.
that is the probability, correct?
Yeah.
Okay. Then expectation will be 1 into 1/4, or suppose, okay. I think it will be something like that when you are drawing a ball, right?
Yeah.
Okay. So how many balls are I have? Okay, for example, let's say I have total. Suppose I'm talking in probability. So I have total four balls. Okay, four C1. Okay,
Yeah.
something like that, right? You are talking. So suppose X1 is something. Let's say I'm drawing a ball with number one. Okay, no, no, no,
No, no, no, no.
no, 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 not
I
like
was
this.
saying,
Ah.
no, no,
Mm-hmm.
I was not saying this.
Mm-hmm.
I was saying that expectation. We know that expectation of drawing any one ball here is
Is three.
10/4. Yeah, 2.5.
Okay. Yes.
Now I'm saying I can choose three balls out of this
Mm-hmm.
four.
Mm-hmm.
Yeah, that is same as choosing one ball out of four. Yeah, that
Okay.
is
Four,
Devil's
three, three.
Okay,
property.
so
No,
you're saying,
supposed to.
okay, you're
Mm-hmm.
saying if you remove three, then the rest of the, I mean, the third ball, then one, two, and four will be remaining. So that is what the answer is.
Yeah,
So
that's
basically, any three can be there, right? Rather
yeah, yeah,
than
any
okay.
three.
Uh-huh.
And three can be there,
Mm-hmm.
but now we can associate now with the probability. Now we have chosen the three places.
Correct.
We
Correct.
have
Correct.
in this thought, like it's not. I have not constructed this thought completely, but this is the direction that's coming to my mind. How I can proceed. Like first I choose three, then I
Mm-hmm.
see associated probabilities,
Mm-hmm.
uh, then I calculate the expectation value.
Correct.
Net
Correct.
expectation of first and second will becomes x1 plus
Mm-hmm.
x2. That
Mm-hmm.
is equals both are like uh, mm, it means different expectation values will be added to get the net expectation. So that is what it's coming in my mind. I need to
Okay,
test
okay,
that.
yeah, yeah, I'm getting your point. Okay, so I think yeah, so in the upcoming slides we have those questions related to that without replacement. Okay,
Okay,
so yeah, so we'll do. So what I'm suggesting as of now, okay, should we discuss it that when slides will end?
yes, sir.
Okay,
When the
fine.
question comes, we can discuss.
Correct, correct, correct. Okay, fine. Because I think I mean, see, here we are just hypothetically we are creating the scenario. If objective will be the clear, right, then we can uh,
Yes.
understand in a more clear way. Okay,
Okay, sir.
yeah, fine. So we can see now. Okay, so this property is fine, right, which we have used, right? This one, right? You got the idea how we can use the like rather than clearly say I'm saying find the expectation of each xi, sorry, expectation of y. You have to identify whether you have to add or subtract or something like that. Okay.
Okay, sir.
So yeah, this is the next question. Here you have to find the expectation of a function of your random variable. Okay. So your function is defined as x square plus 3. Okay. So first find the all the value. Just define x square plus 3 as y or z for your convenience, and then find the probabilities. Okay.
Sir, could you give 1 minute more?
Sir,
Yes.
so in the meantime, I have a doubt. Like,
Yeah.
what is the expectation of a constant?
Okay,
It
you
will be
tell
the
me.
constant. I guess it is the constant itself.
Correct. So basically, how you can compute the expectation?
I have solved this question. I'm asking in general sometime.
In general, I'm asking you, how will you compute the expectation?
For this question,
In general, how will you compute the expectation of a random variable?
uh, sigma xi p of x is equal to xi.
Correct. So just think a little bit. You are saying x is taking a very constant value. Let's say x is taking only
Yeah,
single value, that is 2. Correct.
yeah.
If x is taking only one value, what is the probability? What will be the
Mm.
probability? If x is taking that is only one value.
There is no probability.
What will be the probability? If I'm saying x is taking only one value, then what will be the probability?
Only one value. One of one.
One, correct? Because it's a sure, right? It's taking only one value, correct?
Yeah,
And what is the expectation of x? Summation of x into
yeah,
px, so it will be 2 into 1. That is 2. That is what is the x is taking basically. It's taking a single constant value, right?
yeah.
The expectation of a constant, nothing but that constant. Yeah.
Okay.
So some of you enter 5.2, 2.2, 5.2, 4.75, 5.2. Okay, no problem. Let's see the things. Okay. So how will you proceed for this case? Okay. So minus 1, 0, 1, 2, right? So these are the probability minus 1, 0, 1, 2. I mean, these are the values. Probabilities are zero point 0.1, zero point 0.15, 0.3, 0.45, correct? So these are the probability for each xi. Now, what is the next view to find x square plus 3, correct? So what is the x square plus 3? If you put minus 1, what you will get?
4, sir.
4. For 0, 3.
3,
For 1,
4,
4. For 2,
7.
correct? Now, if you see, so for this, what is the probability? 0.1, right? 0.5, 0.3, 0.7. But what is the unique value your y is taking? 3, 4, 7. Yes or no? Yes, no.
Yes,
Correct.
sir.
So what is the probability? What is the probability for 3? What is the probability
0.15.
for 4?
0.4.
0.45.
So we have to add this case and this case, right? Because it is taking value 4. I mean, I'm saying probability y is 4 when x is minus 1 or x is 1, right? In these two, I'm getting. So I have to add this probability. It will be zero point 0.4, and for 7, it's a 0.45. Is this clear so far, so good?
Yes, sir.
Okay. And we know how to compute the
But why are
expectation
we
of
ignoring one, sir?
where we are ignoring one.
I mean,
We didn't ignore one.
uh,
See, when y will
So,
take 4 for minus 1 and 1, right?
yes, sir.
We have to add this probability. You
Okay.
got it?
Okay, sir.
So, I mean, because y is taking 4 when x is minus 1 or x is 1, right?
Yes, sir.
So, we have to add this probability. Fine.
Okay.
Expectation of y is what? Summation of y into probability y equal to y. So, it will be 3 into 0.15 plus 4 into zero point 0.4 plus 7 into 0.45, which is nothing but uh, this,
0.45, 1.6.
yeah, zero point 0.4.
5.2.
5.2 is the answer, right? Yeah, because it's a 0.45, 1.6. Yes. Yeah. So let's see the solution. Yeah, the same thing we can see. The gx I have taken for y. You can take anything. You can take z. So gx is nothing but it denotes the function of your random. So it will be correct answer is the 5.2. Any doubt?
Sir,
Hmm.
I have a doubt.
Yeah, go ahead.
So when we are calculating, we are finding expectation of y here, right, sir?
Hmm. Hmm.
Can we also calculate instead expectation of x square?
Hmm.
Then with that we can add 3. That is also correct, right, sir?
Correct. Correct. Yeah, absolutely. Because
Okay,
see,
that way also I'm getting the same answer actually.
yeah, because see, this means what? This is nothing but okay. Let's can I do like this? Suppose can I do expectation of x square plus expectation of 3?
Yes, sir.
So this is nothing but expectation of x square plus 3.
Yes, sir.
You will get the same answer.
Yes, sir.
Should I do or is it fine?
I'm getting the same answer, sir.
Yeah,
So
because
that's correct
what
only.
x square, what you have to do, it will change. It will, I mean, it will be okay. So it's a minus 1, 0, 1, and 2. This is x. So x square will be 1, 0, 1, 2. Correct? Sorry, 4.
4. Yes, sir.
So you have to add the probabilities for this, right? So x square will be basically it will be 0, 1, and 4. So for 0, it's a uh,
0.15.
0.15. For 1, we have to
Point,
add this.
yes, sir. Point 4
Then,
and 0.45.
yeah, so expectation of x square will be 0
Point
into
4,
this, so zero point 0.4
4
plus
plus
4 into zero
1.8.
point 0.4. 1 point,
1.8. 1.8 plus 0.4 is 2.2.
yeah. So, and then, so zero
With
point
that,
0.4,
when we get
yeah. So, at the end, expectation of y will be, you have to add this expectation of x square plus.
plus 3.
Anyway, so
Yes.
we have just, we have to apply the properties of expectation. Okay.
Oh, okay, sir.
Yeah. So, let's move to the next question. Yeah. So question is there in a box. So there are some sub parts for this question. We have to do carefully. So first part is saying in a box there are 10 chocolates. Now in the next upcoming or here you will get the idea of the without replacement. Let's see. So sorry. In a box there are 10 chocolates of which 6 are milk chocolates and 4 are dark chocolates. Two chocolates are drawn at random without replacement. Okay. So now this see the meaning. Find the probability that one dark chocolate is drawn among those two randomly drawn chocolates. Okay. So you have to just find the probability. Okay. So you can define x or y, whatever you want to define x as a random variable, which will represent number of dark chocolates drawn from the box. Okay? So I'm going to give you some 2 to 3 minutes, and do let me know if you need another time.
This question is not related to week 10 content, right, sir?
No, it is related to week. So basically here you will get okay. So once you will no. So when you will do the questions from week 11, right?
Mm-hmm.
So the similar kind of questions you will know like how to do in with the two different way. I mean two
Oh,
different method. Okay. Here we are doing the like we can do the manually. If you will see the week 11, right? In week 11, in such kind of scenario, it's called a hypergeometric distribution. Okay.
okay.
So you can directly apply the expectation of hypergeometry. Or else, suppose, I mean, this question we have put it here because suppose you, for example, you don't know the hypergeometric and you forgot the what is the expectation of hypergeometric, then how you can do the same question in a with the I mean our standard method.
With the
Okay,
previous weeks. So,
correct. Yeah.
okay.
So do you need another time limit, anyone?
Yes, sir. Just 1 minute, please.
Okay, fine. Yeah, sure. So do you see the solution? Okay, so you have entered 0.53, 0.53, 0.53, 0.24, 0.68, 0.8. Okay, that's it. Okay, now tell me. So what is the question? 10 chocolates, 6 are milk and 4 are dark. So question is there are 10 chocolates, right? Total 10, correct? 6 are milk chocolates and 4 are dark chocolates. So what is the samples we are drawing? How many chocolates? We are drawing 2, right? Which is without replacement, correct? Fine.
Yes, sir.
No, in without replacement, you have seen, right? We can use the combination directly.
Yes, sir.
Correct? So X is defined as number of dark chocolates, right?
Yes.
Drawn. So, and how many dark chocolates we have to draw? One, correct?
Yes, sir.
Now tell me what is the first of all total number of cases in which I can draw 2 chocolates?
10 C2.
10 C2, correct? Now, what is your X? X is I have to draw a dark chocolate. So it will be in how many ways I can do?
4
4
by
is
4
10.
given,
one.
correct?
Oh, choose.
Into. Since in a total we are drawing 2 chocolates, that means second chocolates we have to draw from the milk.
From the dark chocolate. Sorry, from the white chocolate.
Yeah, white
Milk,
or milk chocolate. Yeah,
milk
it will
chocolate.
be 6C1, correct? This will be, so you have to just solve this. Okay, we'll get the answer. Okay, is this clear? Okay, I think it is very straightforward. Yeah, 0.53 is the correct answer. Those who entered 0.53, this is the correct answer. Okay, is that all right?
Okay, sir.
Yes, sir.
Fine.
So, in this question,
Mhm,
now like it's like in the previous slide, please.
mhm,
In the previous slide, if you see the question, it says that without replacement. Yeah.
mhm, mhm.
Without, whenever we say that without replacement, it indicates somehow indicates that it's order dependent
Okay,
because
okay.
it's like doing the same thing one
Mhm.
after another.
No, no. Okay,
That is
okay, okay.
that is
Let, let,
altogether
let,
better
let's
than
let's
Factorial
Okay,
divided by 2 factorial cancels out in this particular case.
okay, okay. While I'm doing combination, let me tell you. Okay, suppose you to draw one dark chocolate, correct?
Yeah.
Okay. So in how many ways you can draw one dark chocolate? It will be 4C10. Sorry, 4
Yeah.
by 10.
Yeah.
Correct. And in total, how many sorry chocolates we are drawing?
2.
So what will be the probability to draw a second chocolate?
That's going to be 4 by 10, it's done. But the second chocolate is not going to be the dark that
Dark, right?
yeah.
So what will be the second? Yeah. What will the probability for to draw second?
It has to be white because we are saying one dark, then that's going to
Correct.
be 6 by 10.
Correct. That's it. I'm agree with you. So I'm asking what will the probability for that?
That's 6. That is 1 minus 4 by 10.
Why one minus? We are
Uh,
doing without replacement, right?
okay, just a second.
So
Uh,
if you draw out of 10 chocolates, right? Six are milk, four are dark, right? You have drawn already one chocolates. To draw second, then what will be the
yeah,
probability?
yeah, yeah. It's going to be 6 by 9.
6 by 9.
9.
But we are
Yes.
doing without replacement. We did I see I didn't say or it is not mentioned in the question. First is the dark or second is the white, right? It
Yeah.
can be white or dark,
Yeah.
correct?
Yeah.
Then what will the probability then?
In that
To
case, it's
to white it will be 6 by 10,
yeah, 6 by 10 into 4 by 9.
right? So anyway, we are getting 24 divided by 90, right?
Yeah.
Into 2, correct?
Hmm.
Now
Yeah.
solve this. It will be 24 divided by 10. Okay, let me do here. 4C1 into 6C1. So 10 factorial divided by 2 factorial into 8 factorial.
Yeah.
So 4C1 into 6C1. So 10 into 9 into 8 factorial divided by 2 factorial into 8 factorial. So it will get cancelled out. So
Yeah.
what we got? 24 divided by 90 divided by 2 factorial.
Yes, sir.
So again it will be 2 factorial into 20 divided by 90.
Hmm.
Correct?
Hmm.
Correct? The same
Yeah.
thing we got.
Yeah.
Okay. So that's
Hmm.
why we can use the combination directly here.
Hmm. Hmm. Hmm.
Understood?
Okay.
Yeah. Okay. So now let's move here. Sorry, let's move to the next part of the question. It says the same thing here. You to find the expected number of dark chocolates drawn. So here you have to think. Okay, what are the possible values your x will take? Okay, and then what will the corresponding probabilities for each values of x? Okay. So if you are drawing two chocolates, so what will the possible values your random variable will take? Here we are interested in number of dark chocolates. Yeah, tell me what will the possible value your x will take?
0, 1, and 2.
Correct, because we are drawing number of see we are drawing two chocolates, right? And which are we are so it's a dark chocolate. So it can be possible you have drawn two chocolates. Possible all are milk, correct? Or one are dark or all are dark, correct? So that's why your x will take 0, 1, and 2. So find the respective probabilities for that and calculate the expectation. Did you get the idea of the question, correct?
Yes, sir. So in this question, we are trying two chocolates. Then we need to find a subtraction of only those two now.
See, expectation you can define simply x, right? What will be your x?
0, 1, 2.
Okay, then find the probability when x will take 0, find the probability when x will take 1, and find the probability when x will take 2. Fine?
Yes, sir.
Yeah. Okay, so anyone, do you need extra time limit?
No, sir.
Is it for all or any one of you want extra time?
Just 5 seconds.
I have minimum 36 I can give.
Sir, I'm getting in decimal values.
Uh, is it maybe some calculation mistake?
Okay, sir.
Okay, you can check. I'm not sure if you're. It can be in decimal. It's not a problem.
Okay, sir.
Yeah. So should we see the solution or
Fine with me, others.
okay? Okay, let's see then. 0.79, someone is enter 1.25, 0.8, I think they have rounded off 1. Okay, let's see. First of all, tell me, so now here you have to be little bit careful. So what is the, as I told you in the, like in the first question which we were discussing, right? Their statement was little bit, I mean, we were not clear which ball we have to draw, something like that, right? So if you see, we have to draw, I mean, we have to find the expected number of dark chocolates drawn. Okay. So you can simply do, first of all, what is the, suppose I'm saying X is number of uh, dark chocolates, right? Which has been drawn. Now, since I'm, how many balls, sorry, chocolates we are drawing? Two, correct? So X can take value 0, X can take 1, and X can take 2. Yes or no? Right? If you're drawing two chocolate, it's possible there is no dark
Yes.
chocolates in your sample. There is one chocolates in your sample, and maximum value will can be 2, correct? So we have to find the respective probability. So what is the probability X will take 0? See, you have 6 milk and 4 dark chocolate. What is the probability X will take 0? First of all, what is the total number of cases?
1
10
upon
C2.
3.
10C2, right? Because we have total 10 chocolates and we have to draw 2 chocolates, correct? Now, what is the favorable? So, in favorable, if you see, I'm interested in 0 dark chocolate. That means all are milk chocolates. Or I can say, out of 4, I'm going to draw 0 into all are milk chocolates. Yes or no?
Yes, sir.
Is this clear? Now, so if you see probability for X equal to 1, see total case anyway, it will be same here. I have to draw one dark chocolate. So what is the, in how many ways you can draw one dark chocolate?
4C1.
4C1. Since we are drawing two
6.
chocolates, so second will be from milk chocolate, right? Is this clear? What about, uh, sorry, to draw two chocolates, two dark chocolates? Tell me,
4C2.
4C2 into 6C0.
correct? So what we have to do to find the expectation, right? Expectation of X, it will be 0 into probability X equal to 0 plus 1 into probability X equal to 1 plus 2 into probability X equal to 2. So whatever the answer we'll get, that will be the correct answer. So let's see. Okay, so here answers are there, calculations are there. So yeah, correct answer is the 0.7. Is this clear?
Yes, sir. I got 0.8.
Okay, I think you rounded off till okay, no problem. Okay, so funda is clear, right? In this case,
Could you please show the previous slide, sir? 1 minute.
this one,
Yes, sir.
okay,
Okay, okay, sir. Thank you.
clear. Yeah.
Okay.
Okay, next question is, I think this all things see, which we are doing right here. This all things. This is something, this question, if you see, if you when you will see the lectures of week 11, right, these all things you can do within a second, because there is some distribution related to these kind of things, and you can directly apply the formula. But now we are seeing, if we don't know the formula, then how we can proceed. That's the something we are doing here. Okay, so question is, past records of a football club in golden goal matches are analyzed. Assume that the results of a match is independent of the other matches. So it says, so xi is will take value 0 with probability zero point 0.4, and it will take value 1 with probability zero point 0.6. So 0 means team lose the game, and 1 means they will win the game. So what is the expected number of wins in 5 matches? Okay. So you have to find for 5 matches. One hint or note is given to you. Simply xi you can define. Xi is the random variable associated with the ith match of the club. Okay. Any one of you can tell me how will you proceed for this to find the for the 5 matches?
Because they are independent, we can do for it is expectation like Bernoulli's index.
Okay, forget about Bernoulli. We know we know Bernoulli, but forget
Okay.
about you don't know Bernoulli. Then how will you proceed?
So it is 0.6, 0.6, 0.6 like that. We have to add it 5 times. We get the
Correct.
answer.
Basically, we have to use the linearity of the uh, linearity property of the expectation. Correct. So I'm going to give you some 3 minutes. I think that should be more than enough for this question.
So, in this similar kind of question, one thought came to mind, like
Hmm.
saying that when we are doing 5 matches consecutively, yeah,
Hmm.
similar cases, it's we are seeing that wins in the 5 matches.
Hmm.
So it's we are doing that in the first match I win and I win the second match,
Hmm.
and I don't know in wins. What is expected number of wins? It's saying that, yeah, it's xi equals 1 in the first match,
Hmm.
and xi equals to x2 is equal to 1 in the second match, and
Hmm.
the similar thing.
Hmm.
So, can we translate this expectation somehow in the terms of that and or notations that we used to do for this, like in the PNC?
Hmm.
Can we do that? Like,
So you I mean you basically you wanted to do like probability of x, I mean x1 is taking 1, x2 is taking 1, x3 is 1, x4 is 1, x5 is 1, right?
yeah, in a sense, this is and.
So basically, no, it's we have to add all the for all 5.
Yeah, we are doing that for
Correct.
the application.
So it will be basically, see, value, I mean, see, when they will win, when it will take 1, correct?
Yeah,
1 into probability of x equal to 1, x1 equal to 1, correct?
yeah, yeah,
Plus 1 into probability x2 equal to 1.
yeah,
Then 1 into probability x3 equal to 1.
yeah,
Plus up to 5. That is something you are trying to see, correct?
yeah.
Yeah. The same thing. Actually, this is the backend algorithm for your expectation.
Mm-hmm, mm-hmm,
Okay.
mm.
Yeah, so I think someone mentioned, I don't know her name. It's actually it's called Bernoulli trial. If I have something which I have only two possibility, either success or failure, okay, that's called the Bernoulli trial. So
Sir,
in Bernoulli trial,
uh,
actually
I
expect
I'm not
in.
still understanding one thing there, like the probability thing that I need to like understand a bit more uh,
Mhm.
there. Like in the notation in the Bernoulli's trial notations, that's
Actually,
and
it means, okay, it means xi is, there is two things, right? 0 or 1, correct? So
yeah,
for 0, xi will take value 0 with probability zero point 0.4. Xi will take value 1 with probability zero point 0.6.
yeah.
Okay. Means xi taking only two value, 0 and 1. For 0, probability is zero point 0.4. For 1, probability is zero point 0.6.
So in
Understood?
Bernoulli's, there is one more term beside this choose term, that is n choose. That's Berno in the
That's a
Bernoulli.
binomial.
Oh, yeah, yeah, it's
Okay. If you
binomial.
will add n IID Bernoulli random variables, right, you will get the binomial.
Sir,
Suppose
is not this question concerned to the binomial instance?
correct, correct. That's why see, I told you when I started this question. These are things we are doing. Suppose we don't know the algorithm, right? We don't know the binomial or we don't know the Bernoulli. For example, you forgot the what is the expectation of binomial, correct? But if you know the how to compute the expectation, if you know how I can find the things, how I can apply the linearity property of the expectation, even you forget the formula, you can calculate it. That is the something we are doing here.
Okay.
Okay. Yeah.
So, but when we came to like Bernoulli's and binomial thing, na,
Hmm.
then one thing came like it is not just we are not talking about the single match. So it's not just the value 0 or 1. That's why it's not a case of just binomial. It is case of Bernoulli's because we are doing the same matches 5 times. We are
I
repeating
will
an
say,
experiment five
I,
times.
I, I will clarify. Don't.
Okay.
See here. And let's see the solution part itself. So for each xi is what? Random variable associated with the ith match of the club, right? What will be the expectation of xi? It will be 0 into zero point 0.4 plus 1 into zero point 0.6. Yes or no? Correct? So it will be zero point 0.6, right? Let's define another random variable s, which represents the number of matches won by the club in all 5 matches, which I can do x1 plus x2 plus x3 plus x4 plus x5. Correct? Yes or no? Are you getting? See, S is what? X1 plus X2 plus X3 plus X4 plus X5. So each Xi will take value 0 and 1. I mean, for the first match, you can win or lose. Same for the second match. Same for the third match. Same for the fourth match. Same for the fifth match. Yes or no? So in a way, I'm interested to know what is the expectation of X to win the match. So like expectation of Xi is what? We saw 0 into zero point 0.4 plus 1 into zero point 0.6, which is nothing but zero point 0.6, correct? So for expectation of s, it will be, that tell me, we have to apply the linearity property, right? So it will be expectation of x1 plus expectation of x2 plus expectation of x3 plus expectation of x4 plus expectation of x5. So it will be zero point 0.6 plus zero point 0.6 plus zero point 0.6 plus zero point 0.6 plus zero point 0.6, which is nothing but 5 times zero point 0.6, which is nothing but 3. Okay. Now, if you are coming to the Bernoulli, right? So in Bernoulli, suppose I'm saying x is defined at the Bernoulli with success probability p. Success probability p means x will take value 0. Uh, I mean with x will take with x I will take value 1 with success probability p. It will take value with 0 with probability 1 minus p. Here you can see it is taking 1 with probability zero point 0.6. Then it will take 0 with 1 minus zero point 0.6, that is zero point 0.4. In case of Bernoulli, right? What is the expectation? It will be 0 into 1 minus p plus 1 into p, right? So that is nothing but p, correct?
Yeah.
If you come to the binomial, so what is the binomial says? If I will add, let's say independent Bernoulli random variable, right? It will become the binomial distribution with parameter n and p, correct? And means number of variables you are adding and expectation of x. Let's say this is y. For example, this y denotes x. So expectation of y in case of binomial is the n into p. We will see in week 11 how this n into p is coming. So this is n into p. Now if you see here, I have defined s as a summation of I equal to 1 to 5. And all are independent, right? So expectation of s will be what? N is what? 5 and P is what? 0.6. I can directly compute the 3. Okay.
Mm.
So both are the correct. Suppose you don't know the this Bernoulli and binomial, then how you can do the same thing without knowing the formula? Understood?
Okay. It's in Bernoulli that is considering a single experiment, but it's in
Correct. Yeah.
binomial.
And
But
binomial is some an independent experiment.
okay.
Okay. Means you can simply say, suppose you are tossing a coin, right? You will get head or tail, correct? In a single track. And suppose I'm interested to know the number of head obtained in, let's say, 10 independent throws. Okay. Then I will go for the binomial. Okay.
Okay, sir.
Now, this is something definition about variance and standard deviation of a random variable. What is the variance basically tells us? expectation doesn't give the information about the variation or spread of the values that a random variable can take, right? Expectation and but while variance gives us the information about the spread of the values about the mean or the average of a random variable. I will tell you why. What is the variance of a random variable defined as? I mean, how? There is a formula called expectation of x square minus expectation of x whole square, and the standard deviation is nothing but square root of the uh, variance of x. Okay. Now, anyone of you, okay, before going to standard, just let me know. Suppose I have two things. Let's say I'm just two university, A and B, and there are some packages. Let's say 10, 20, 30, 40, 50 in lakhs, and in university B, these are the packages of some five students. Tell me what will be the average annual average package here?
30,
30, and here
30.
now in both case averages are same, correct?
Yeah.
Ankit is saying PX expression of binomial distribution. Ankit, we'll discuss in those all things in week 11. Don't worry, okay? Here
Okay,
we'll get confusion. Yeah, okay. I
okay,
mean, it's something. It's basically n choose x, p raised power x, 1 minus p raised power n minus x. Okay, this is the PMF
The,
of
the
binomial.
thing is, I only didn't get why we are still multiplying with the 1 minus p raised to the power n minus x.
Okay, it's because in binomial, in Bernoulli, what is the PMF for Bernoulli? You know, p raised power x, 1 minus p raised power 1 minus x. Okay,
Uh, hmm,
okay.
okay,
Yeah.
so
So for in binomial, we are doing n trials, right? See, it means, of course, okay, basically, you can simply say, suppose you are going to toss a coin 10 times, right? For example, you and your success is you are interested in getting a head. Suppose you got 4 times head, okay? So
okay,
it will be p raised for 4, okay?
yeah,
That means 6 times you are not getting the head, okay?
yeah,
And in how many ways you can choose? 10c4, fine. That is some idea, okay? We'll see detail in week 11. Okay, let's focus there. So which you okay? So in reality, are the data are same where average is same?
No, sir.
No, right? There is some variability in data set, right? Correct. So
Yeah,
that's why
but
we are
in the
using variance. Okay. Okay. So we are using variance, but we are using another thing called standard deviation square root of variance. Why we are taking the square root of variance? What's the need of taking the
Because
standard?
the unit of variance is squared of
Correct.
a unit
Correct.
of.
Very good. Yeah. Because it is the easier. I mean, it will be unit will be the same, right? As original data. Okay. For example, my random variable is let's say age of person something. Okay. Your variance will be let's say 40 year square. Correct. But you will take once you will take square root, so it will be square root of 40 year because square root of year square will be year. So it will be original unit. So next question is the same. I mean, the information is the same. For fourth question, you have to use compute the variance of number of wins in 5 matches. Here you have to be careful. Where I can. So here you have to use the variance of S as a variance of summation of xi, right? So can we separate all xi or not? Are you getting my question?
No, sir.
No. Okay, just do on your own. I will discuss. Fine.
So
Easy.
can the variance be negative, sir?
No, it can. That is the something. Variance cannot be negative. If you are getting the variance in negative, that means you are doing something wrong. Because variance is defined how? It's nothing but
Because E of
expectation.
x square and E of x are same in this case, sir.
That's a different thing. See, that's the different thing. What I'm saying, variance is something like this, right?
Yes, the formula of the variance is E of x square minus E of x the whole square.
Okay, that is the expansion of this one.
So when we are doing, we are getting 30 minus 30 square. So sorry, 3 3 minus 3 square. So
Why are you doing 3 minus 3
E of
square?
x square is also,
Uh, 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 uh. Do we need to do E of S square, or we have to find the variance of each xi? Okay, you know, after this expansion of this, we are getting this case, right? Is this fine, right?
yes, sir, E of x the whole square, correct.
Yeah. Okay, just think. Okay. We have to find the variance of number of wins. So we have to find the variance of S. Okay. So expectation, okay, you can do, see, expectation of S square minus expectation of S whole square. But before that, you have to find the expectation of S square.
Sir, could you give 3 minutes more?
Okay, fine. Once this time will end, I will Hello, hello, am I audible?
Yes, sir.
Okay, yeah, sorry. Okay, let me see the responses. 1.2, 12.246, 150, 0, 1.2, 8.9. Okay, fine. Okay, so in this case, if you see, so all the previous scenario is same, right? Okay, so basically we have to find the expectation for each xi. Yes or no? Right? See, we have to, so basically we have to find the variance of summation of xi, correct? That means variance of sorry, x1 plus x2 plus x3 plus x4 plus x5. But if you see here variance for, okay, can I write as a variance of x1 plus variance of x2 plus variance of x3 plus variance of x4 plus variance of x5 here or not?
Yes, sir.
Why?
They are independent.
Correct. So this is something in case of, see, in case of expectation, right? Suppose I'm just telling you with the help of two random variables. Suppose I have two random variables x1 and x2, right? Whether this is dependent or independent doesn't matter. But in case of expectation, right, I can simply write. Okay, I can simply write expectation of x1 plus expectation of x2. But in case of variance x1 plus x2, what we are getting? Variance of x1 plus variance of x2 plus 2 times of covariance of x1 comma x2. But if x and y are independent, x1 and x2 are independent, we know if these two are independent, then covariance will be 0. Correct? Yes or no? If two random
Yes,
variables
sir.
are independent, covariance will be 0. So this will be 0. That's why we are getting variance of x1 plus variance of x2. So make sure your xi's are independent. Okay. So here we can simply find variance of xi. So which is nothing but expectation of xi square minus expectation of xi whole square, right? So we had calculated expectation of xi, right? We need to calculate expectation of xi square. What was the value xi will take were taking? 0 and 1, right? With probability zero point 0.4 and zero point 0.6. Correct? If you take xi square, you will get again 0 and 1 with same probability. Correct? So what is the expectation of xi square will be here? Again 0 point 0.6. Right? Are you getting 0 into zero point 0.4 plus 1 into zero point 0.6? Is this clear? Yes, no?
Yes, sir.
Are you getting right what I'm trying to say here? So expectation of xi square is zero point 0.6. Expectation of xi we had calculated in the previous question, which is zero point 0.6 square. So it will be zero point 0.6 minus how much? 0.36. So it will be 0.24. So variance of each xi is 0.24. So variance of summation of I is equal to 1 to 5 xi is nothing but, I mean, we have to add this 0.24 plus 0.24 plus 0.24 plus 0.24. So it will be basically 5 into 0.24, which is nothing but 1. Is this clear? Any doubt? Is that all right for everyone, correct? Or is this any doubt for
Sir, last part, can you explain once again?
this part?
Yes, sir.
Okay, so variance of single xi is what? 2.24, right? I means for any of the five, correct? I will be 1 to 5, correct? And we had to calculate the variance of S. That means variance of summation of xi, right? Correct? So that means variance of, we know we have seen variance of x1 plus variance of x2 plus up to variance of x5, right? So it will be 0.24 plus 0.24 plus up to 0.24. How many times? 5 times. So it will be 5 into 0.24, which is 120. I mean, but two decimal places, so 1 point. Is this clear?
Yes, sir. So, in question, it was not given like X is independent or dependent. So,
It's there. Independent of the other matches.
okay, sir. So, if there was in question, it was not given like that, then
No,
what
no,
do
it will
we?
be mentioned. Okay, it will be mentioned. It will sometime it will depend on the context of the question, but almost every time it will be mentioned. See, only then I can apply the properties of variances, right? Otherwise, you will get confused, right? Whether I have to add the covariance part or not, something like that. Okay.
Okay, sir.
Yeah. Is that all right for everyone? Yeah. So
Okay.
let's move to the next part. So this is just a general question. I mean, the suppose you have random variable y is equal to as plus b. Okay, the which of the following will be true? Okay,
First and third. Sir.
okay, first and third. Okay, are you able to choose both options or not?
No, there is
So,
no
there is no option.
no
Ah,
choice. No response.
okay, okay, fine, fine. So first and third. Okay, so I got two votes for first and third. What about others?
First and
Yes, sir.
third.
First and third.
Why
Same.
not second? Why not second? What's the problem with second?
Because adding a constant to each value won't change the variance.
Correct. It will not affect the variance at all. Correct. Right? Yeah. So correct. Correct. So I mean, I hope you got the idea. This variability and expectation. Okay. So I think we have ended up with the slides. Okay, that's all about slides. So by the property of expectation and variance, first and three are correct. So we end up with the slides. Okay. So do you have something any
The
doubt? So we can.
activity question, will you be able to take it now, sir?
Okay, fine, fine. Okay, Swarnam, that about that without replacement you are telling, right?
Yes, sir.
Okay. So let me give you a hint. Actually, it's a very long procedure. Okay. Initially, I got also confused, but I thought so. It will be something like that. Suppose exercise what 1, 2, 3, 4, right? With some probability with point 1, point 2, point 3, point 4. Okay, that is something we are not discussing here. Okay, I will tell you how it will affect. If you are doing without replacement, right?
Mm.
Always number will affect, right? Suppose, for example, I have drawn one ball, right? So it will be like what is. I mean, there will be lots of random variable. For example, x2, given that your x1 is 1. X1 is 1 means in the first draw you have drawn one random variable. Then what is the x2? When it is possible you have drawn ball with number 2, right? It's a conditional probability you have to find.
Probability. Okay,
Correct?
sir.
It will be x1 is 3, right? Are you getting what I'm trying to say?
Yes, sir.
Okay. Similarly, it is possible it will be x1 equal to 1, x. So it's a long procedure to add all the probability. And you know what is the conditional probability, right? So that is something we have to
Yes.
do. Okay. That's why
Okay.
it's a without replace. Sorry, with replacement. With replace, we have the total number of balls, right?
Okay.
So
Okay,
probability
sir.
will not affect. So what you can do if you're interested, right? So you can solve something like that, and we can discuss on. So which
Okay.
activity you have done?
10.5 question number 3, sir.
10.5. Question number
3.
3. Okay. The variance of number of tickets sold in a day in an opera theater is 25. For each ticket sold, the profit obtained is 25 rupees. Then what is the variance of the profit obtained in a day in rupee square? Okay. So okay. Variance of a number of X sold in a day in opera theater is 25, right? So that means what is your X here?
Um, X, X is number of tickets.
Number of tickets sold in a opera
Uh,
theater, right? In an
yes.
opera theater, correct? Now,
Uh,
tell me, then variance for X is 25,
correct. Correct, sir.
correct? Okay, let me tell you. So this is basically variance of this is your X. Till now, this is X, right? Till here, correct?
Okay.
So variance of X is 25, correct? Now,
Yes, sir.
how many tickets is sold? Sorry, for each ticket sold, the profit is 25
25
rupees,
rupees.
correct?
Correct. Correct.
Correct. Now, suppose I'm saying X, if X is represents the number of tickets sold, right?
Correct. Yes, sir. Number of tickets sold.
If you sold one ticket, what is the profit?
25 rupees.
If you sold a two tickets, what is the profit?
50.
That means 2 into 25.
Correct.
If you sold three tickets, then
3 into 25.
3 into. If you sold four tickets,
4 into
4
25.
into 20.
if you sold X number of tickets,
X into 25.
25 into X, right? So we have
Correct.
to. So this profit is 25 times of X.
Okay, okay. So we are squaring that.
Correct.
Okay.
Got it?
Okay,
Yeah.
sir.
Yeah.
Sir, one more question, sir.
Hmm.
Activity 10.6, third question.
10.6. Okay, next one, right?
Yes, sir. Third question.
Third question. Okay. Among the random variables X, Y, Z, Y is 2X and X. Okay, just let me know. I have three random variables X, Y, and Z, and Y is defined as 2 times of X. X and G are independent. X and G are independent. Means we don't know whether Y, I mean, we have information about X and Z. So variance of X is 2, Z is 7. What is the standard deviation of, okay, X is 2. So what is, okay, basically we have to find the standard deviation of X plus Y plus Z, right? Or
Yes,
that means square root of variance of X plus Y plus Z, right? So
correct.
let's find the variance. We'll do at the last square root. Fine.
Okay.
Okay. So variance of X plus Y plus Z will be what? So we don't have the information about. So we know variance. What is the Y? Y is 2 times of X.
Correct.
It will be variance of 3X plus.
Z.
Now X and Z are independent, right?
Okay, okay,
So
okay.
I can write variance of 3X plus variance of Z
Variance of
because
Z.
these two are independent. So
Okay.
I will be having 9 times of variance of X plus variance of Z. And we have variance of X is 2, variance of Z is 7. So 9 into 2 plus 7. So it will be 25. So standard deviation will be
Root
square
over
root of
25. Okay.
so 5. 5 is the answer.
Okay, sir. Okay. Thank you.
Yeah, 5 is the answer. Yeah, correct. Yeah.
Okay. Thank
Anything
you.
else?
Nothing.
So in 10.3,
10.3. Okay. Which question?
sir, question number 3 and 4.
Question number 3 and 4. It's a very simple one. Okay, it's a very. Now you will tell me. You have just done the that example for dark chocolate, milk chocolate, right? You have to do in the similar way. See, now you in this case it is not mentioned with replacement, but without replacement, right? But here we are talking about people, right? It will be without replacement, correct or not? Yes or
Yes,
no?
sir.
See, there are 20 juniors developers. Okay. So just write like this. You have total 20 juniors, right? And 8 are men and 12 are women. 8 are men, 12 are women. 5 junior developers are to be promoted to senior level. What is the expected number of women in the promoted developer? So what is the, how many people we have to promote? 5, right? X will represent what? Number of women, correct?
Yes, sir.
Promoted to the senior level, right? Tell me one more thing. Is it very similar? We had 10 chocolates, 6 were milk, 4 were dark. We had drawn 2 chocolates. X represent the number of dark chocolates. Correct? Okay. So what was
Yes.
the expectation of, sorry, what was the, when X will take, for example, X will take how many values? 0, 1 and 2. Correct?
Yes, sir.
So what is the possible value probability for X equal to 0? Tell me. In this case,
Sir,
dark chocolate.
in dark chocolate, 2 4 0.
4C0 divided by 10C2, right?
Yes, sir.
Here, what is the possible values your X will take?
X will take 0 to 5.
0 to 5, right? What is the probability for X equal to 0? Tell me. That means 0 number of women promoted to the senior level. What is the total number of case?
20 C5.
Right? Then what? That means if zero number of women is promoted to the senior level, that means all are men.
Yes, sir.
It should be 8C5. What will the probability of X equal to 1?
Okay, sir. Got it.
Got it? So similarly,
Yes,
you
sir.
have to proceed, correct? Fine. And what
Yes,
about
sir.
next? So, okay, any one of you can tell me if you have done. So you can simply explain to her if you are interested.
So fourth question.
Yeah, she has the doubt in question number 4. Okay, no one?
So for the fourth question, we have to take random variable x as number of defective, and
Fine.
then
See, how
here it
many?
is.
Correct. So there are 1,000 mobile phones in a mobile shop, of which 100 are defective, right? A retailer buys 20 mobile from the wholesale shop for a total price of 2 lakh rupees. The retailer gets 2,500 rupees profit if the mobile phone is not defective, so and 10,000 rupees loss if it's defective. So tell me, if see, it's a note one written is there. If net profit is negative, then we have to return minus. So 500 is the profit. So it will okay. What is the possible value your X will take? Tell me. So there are only two things, right? Profit and loss. Correct? Yes or no?
Yes, sir.
So what will your X will take? Tell me just by seeing the question.
0 and 1.
No, 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 no. We are talking about money here, right? Should X okay. Should X will take 2,500 and minus 10,000 or not? Yes or no? Are you getting? See, for X, what is the X? First of all, we are interested in to profit is right, profit and loss. Correct or not? See, I'm asking you so that you can guess something, right? See, first of all, tell me.
2,500 and 10,000.
So X will take 2,500, right? Because see, there is see, what is the case? Whether your mobile phone is not defective and mobile phone is defective, correct? Ankit has sent something more. Okay, that is something I'm talking about, right? Okay. So here X will take basically cut this here. Yeah. So
So
X will take yes.
so this image is solved by myself only.
Okay, okay.
So can we find the expectation of x here without using the Bernoulli? That is
Without using?
Bernoulli formula n into p.
Yeah. That is something I'm trying to explain. See here in week 10, we are not going to use any Bernoulli binomial. We are just going with the our standard procedures. Okay. We are not going to use any Bernoulli binomial at
Yeah.
all. Fine. So you can see here your X will take how much? 2,500, right? So for 2,500, what will the probabilities? Yeah, I think who asked this question? I think.
So could you please repeat?
See, okay, first of all, tell me what. So there are total 1,000 phones, right? Out of which 100 are defective. Okay, so retailer buys 20 mobiles and total price of 2 lakh rupees. Question is, retailer gets will get 2,500 rupees profit if mobile phone is not defective and 10,000 rupees loss if it is defective, right? Yes or no? So
Yeah.
what will the, okay, tell me what will the X will take? What value your X will take? X, I'm a random variable.
Sir, X can take like 0 to 20 values. 0 to 20.
Okay. X will take 0 to 20.
Yeah, like it's saying that he is buying 20 phones.
Mm-hmm.
So either none of them is defective or one is defective or all 20 are defective. If you are defining X to be the number of defective products,
Okay. Can,
so
can, 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 okay. That's okay. Suppose I'm saying X is, see, anyway, what is the X? We are talking about the expected profit, right? Okay. I mean,
yeah,
correct. So what is the X? So we are getting 2,500 rupees profit and then loss will be 10,000, right?
yeah.
These are the two scenario for those 20 phones, right? Correct. Yes or no?
Yes, sir.
Yeah, so it's their plus and minus and their combination of 2,500 and minus 10,000, no? Not just
No, no,
individual.
okay. You will get the idea. Okay, what I'm trying to say. Okay. So for 20 phones, okay, as per the question, he will get the profit of 2,500, right? If no phone is defective, correct? If phone is defective, he will be in loss of 10,000 rupees. Correct? Yes or no?
Yes, sir.
Right. So I'm just assuming X will take 2,500 and when phone is not defective, right? If it defective, he will be lost, right? Now in the question it is mentioned for 1,000 mobiles in a mobile shop of which 100 are defective. So what is the probability for being defective?
That's 100 by 1,000. That's
1 by 10.
yeah,
Correct? So what is the probability of being non-defective?
0.9.
9/10.
Okay. No, okay. Okay. So here, what will the probability when it is in not defective, right? Only then this 2,500 value will be there. Correct.
Yeah.
Okay. So that means what will the probability?
Not defective, it's zero point 0.9.
No, no. See this 2,500 for how much? It's for all
2,500
20.
into 9/20. 9 by
No,
10.
no, sir. This is in the question. It said that for one phone, each phone, na, rupees get profit if the mobile phone is not defective and 1,000 rupees loss for each phone, sir. Not for just one.
Yeah. Correct. 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 So it will be. So it will be 9 by 10, right? And it will be 1 by 10. Correct.
Yeah.
Okay. So what is the expectation of each xi? Xi means we are talking about ith phone. Yeah, correct, correct. Yeah, thanks for the correcting me. It's about basically ith phone, right? For ith phone, xi will take 2,500 and this is the profit and this is the loss, right?
Yeah.
And probability will be 9 by 10 into 9 by 10 and 1 by 10. If it's not defective, for defective it's 1 by 10, right? What is the expectation? 2,500 into 9 by 10 minus 10,000 divided by 10, right? Yes or no? So far, so
Uh,
good.
expectation of fire.
See, basically, we are interested to find what is the net profit. If you can see, what is the question? Expected profit earned by the retailer. Here we are, we are interested to find the expected profit for ith phone, right? Can
Yes,
I
sir.
say, right?
Yeah.
Right?
Mm.
So what is the, can you calculate this? 2,500 into 9. I think it's 945, 22,500, right? Minus 10,000 divided by 10, correct? So it will be 12500 divided by 10. So 1250, right? So 1250 is the expected profit for a ith phone, right? And like that, we are taking how many phones? 20 phones, correct? Yes or no? So for all expected profits, so it will be basically y is nothing but summation of I is equal to 1 to 20 xi. So it will be 20 into 1250. Okay. So basically 25,000 is the expected profit for all 24. Okay. This is the, is this clear? Is
So
it
here,
clear?
sir, you are taking
Yes.
advantage of that the net profit will be the summation of the profit that I am earning at each
Correct.
uh
Correct. So
position.
I had taken like this because it's okay. See the question. Question is asking for expected profit, right?
Yeah.
I'm talking about total profit, right?
Hmm.
Okay. So why I should take basically what is the net profit for a ith phone? So for ith phone, ith means for a single phone, I will get profit like this, or I will get it will take 2,500 if it's in not defective. If it's defective, then I will be in loss of 10,000 rupees. Correct. So for ith phone, so my expected profit is 1,250. Correct. Right. Then similarly, we have to calculate for the 24. Is this clear?
Yes, sir.
Fine.
So here XA denotes the profit for each phone.
Correct. For a ith phone,
Net
for a
profit.
single phone. Yeah.
Okay.
Similarly, we have to do for 20. So it will be add up to, we have to add x1 plus x2 plus x3 plus x4 plus up to x20. Okay.
Sir,
Okay.
how to take the x values? Generally,
That is
whatever
easy.
question is asked,
Mhm.
we should take it from
Yeah,
that,
as
or
per the question, yeah. You can simply go to the final question, right? In this question, it was
yeah,
mentioned,
final question. Yeah.
yeah, expected number of profit. Then you have to see to get a net profit, what will be? Either it will be profit or lose, right? I mean, you are something gaining or you are losing, correct? So see,
For every question, we have to see that
correct.
whatever asked is we should take as x
Yes,
value,
yes,
sir.
it will
Oh,
depend. Yeah, like
oh,
as you can see in the, you have seen for the chocolate one, right? We were drawing two chocolates. Then X will take 0, 1, and 2 accordingly probabilities. In the developer questions, we are drawing a sample of 5 people, right? Then X will take 0, 1, 2, 3, 4, and 5 accordingly probabilities will change.
okay, sir. Thank you.
Okay. Yeah. Oh, okay. I think math session is started, right?
Yes, sir.
Okay. Is there
Yes,
anything
sir.
else or should we wind up?
Sir,
Yes.
I have a doubt. Like when a number of trials in an experiment of tossing a die tends to infinity, then in an activity question it is given that uh, relative frequency of random variable converges to the probability of random variable.
Yeah,
What
that is
does
the
this
one.
mean?
Yeah, that is the one concept, that relative frequency and all. Means whenever you will have the large number of, right, tending to infinity means large numbers, then
Hmm?
that relative frequency will be close to the probability. It's one of the definition of probability. Okay.
Sir,
That
I didn't understand this
okay.
definition.
So how we are doing the, okay, how we are calculating the relative frequency
Uh, Frequency of the
divided by
outcome
total
divided by total
frequency,
frequency.
and
Yeah.
how we are calculating the probability. Just think a simpler way. Favorable case
Uh,
divided by total case, right? So this will be
yeah.
same when
Cardinal.
you will be large observations, large data. That is something they are trying to say. Okay, fine.
Yeah.
Yeah. Okay. Okay then. So we'll share the slides. Thanks. Thanks all.
Sir, could you
Yes.
explain the with replacement, without replacement
Oh,
concept,
okay.
and
So
simultaneously also?
simultaneously, then you should rewatch the week 5 and all, right? I think. I do attempted the week 5, week 6 content and all. Okay. Simultaneous and non-simultaneous, I will tell you. So simultaneous means something which occurring one after the other. Okay. So for example, you want to create a password of 4 digits. Okay. Okay. Suppose I want to create a password of 4 digits. So simultaneous means So 4 digit means I have to choose the numbers for the first place and for the second place and for the third place and for the fourth. It's occurring one after the other, right? So this is called something simultaneous. Okay. Non-simultaneous means suppose there are two kind of passwords. Suppose this is the password of pattern A and I have password of pattern B. I mean there is two different password of uh, two different pattern. Then I'm saying you have to choose a password either of pattern A or B. Then it is a simultaneous, sorry, non-simultaneous, right? Because you can choose any one of any of the password for your laptop, right? You can't choose both passwords simultaneously for your system, right? While for us to create a password A, it is simultaneous. To create password B, it is simultaneous. Within B, it is simultaneous. But while it's the situation of choosing A or B, then it will be non-simultaneous. Okay. Now, is this clear? So now come to the is this fine, right?
Yes, sir.
Okay. With replacement, without replacement. So with replacement means suppose for example I'm saying I have 10 balls. Let's say 4 white and 6 black. So with replacement means suppose I have to draw two balls. Okay. So if I'm doing with replacement, so what is the probability? Let's talk about improbability. So with replacement means we are putting back to again in the box. For example, I want to draw a ball. Okay. Let's say you have to draw a white ball. Okay. Then what is the probability for drawing a ball?
So 4 button.
Now I'm saying with replacement. That means you have drawn a ball. Let's say you have drawn a white ball and you again I mean you have to put back again in the box. Then you will be having again 10 ball, right? Then what is the probability? Suppose you are drawing a black ball, 6 by,
6 button.
correct? This is meaning of with replacement. What is meaning of without replacement? Suppose you have this 4 white and 6 black ball and you are drawing two balls without replacement. So without replacement, suppose you have drawn one white ball, for example, then there is no need to put back in again box. So what is the probability for drawing a ball? It will be 4 by 10, correct?
Yes, sir.
Then what will the drawing a black ball, for example,
6 by 9.
6 by 9, because we didn't put back the again in the box itself, right? That is something without replace. Okay, it means total will change actually. Fine.
Okay, sir.
Yeah.
So
So
if
Hmm.
please go ahead, Disha.
there is a with the replacement case, then it's a we need to use permutation or combination.
In without replacement, what we have used,
So combination.
right?
Yes, sir.
Okay, the same thing. So
Uh,
because see, with replace actually it's don't go like this permutation. Don't memorize permutation and combination. In without replacement, why we are using combination directly? Because at the end, if you do, suppose I'm doing one white. Okay, suppose you have to draw one white ball and one black ball, right? Suppose you're interested in one white ball. So it can be WB or BW, right? We have to add both cases, correct? So at then we'll get the combination part. Why to when to use permutation if it's mentioned about order, right? Order are different, order matters. Then uh, we have to use the permutation. Okay, so it's good to go with the counting also. You can go with the counting if you are getting confusion with permutation and combination. Go with the counting thing. Okay,
okay, sir.
yeah.
Sir, could you explain this practice assignment 9, question number 6, using the probability approach?
Question number 9. Question number 9 or 6?
Sir, practice
Practice assignment
assignment
9,
9.
question number 6.
Have you seen the feedback?
Feedback I've seen, but it's not using, it's using the basic of that a combination thing. But I was trying to do it with this probability thing, but I am stuck.
Okay, to get the probability itself, right? That this Ramesh and Suresh you are talking about, right?
Yeah.
So to get the probability itself, first of all, we have to find the total number of case for your total number. Sorry, we have to first calculate total number of case and favorable case, right? See, that is something we can calculate the probability, right? See, are you getting my point? See, here we have to see because see, we have created the cases, right? Case one, case two, case three, case four, case five, case six. Correct?
Yes, sir.
Okay. So okay, so we are observing separately for each cases. So for example, for case one, in how many ways that will happen? In case two, in how many ways that will happen? In case three, in how many ways that will happen? In case four, similarly in case five, then in case six, right? So firstly, we have to find the all the number of ways for your favorable case and all the number of ways for your total case. So it's a simple probability. We have to divide favorable case or divide by total.
So that's okay.
Hmm.
But what I was trying to do is like,
Hmm.
I will only get out when I am getting 10. Yeah.
Hmm. Hmm.
So getting 10 is like 1 by 5, one of the five options, because it's considering the even pages only.
Oh, getting
So
them 1 by 5. How?
I can get only score of 2, 4, 6, 8, and 10.
Ha.
Yeah, so getting 10 when I get out is when I'm having 10,
Hmm.
because it has the 0 at the end.
Okay.
So the probability of getting out at each step is 1 by 10, 1 by 5. That is favorable and by total that I can get. That's 1 by 5.
No, 10 for 10, it's only one case, right?
So
Hmm.
it's 1 by 5 now, because 10 is the outputs that I can get is 2, 4, 6, 8, and 10.
Correct, correct. For even number of pages, right?
Yeah, for even
Ha.
number of places.
Or under.
I will
Okay.
not get out when I have 2, 4, 6, and 8. I will get out when I have 10. So
Okay,
probability of,
okay. You are talking about like this, right? Two, four,
yeah,
six, eight. Okay. So you are saying there are five even numbers.
yeah, there are five in numbers.
0, 2, 4, 6, 8, 10. 6, right? No,
0
it's a
is not
1 to 10. Sorry, it's
considered.
a 1
Yeah,
to 10.
one,
Correct,
yeah,
correct,
one.
correct. Correct. Okay.
So of probability of not getting out is 4 by 5, and
Hmm.
probability of getting out is 1 by 5.
Okay.
So I wanted to construct on this scenario that I am given the two probabilities that I am not getting out with the probability of 1 by 5, and get not getting out is 4 by 5, and getting out is 1 by 5. Now he's saying that I have to play using I have to exhaust all the five chances.
Hmm.
So that means I should not be out in the first, should not be out in the second, should not be out in the third, and so on. Till the fifth
Okay.
round, I should not get out.
Okay.
At
Okay.
each step, I
Hmm.
should the number of the favorable probability of the event is 4 by 5.
So not getting out is 4 by 5, you are saying, right? So
Yeah.
getting out is 1 by 5. No, no. To getting, you will get out only 10 is there, right?
Yeah, only when 10 is there. But if I'm getting 2, 4, 6, and 8, I
Hmm.
will not get out.
What about 3, 5? I think. Okay, what we can do? I think
Give me,
it's hmm, we need to use pen and paper for the. I think that will be okay. So what you can do? You have the access of discussion forum, right? Correct.
sir, discussion for Google discussion for my app.
Correct. Correct. Yeah, that is something I'm talking about. Same. Okay.
Hmm.
So what you can do, just put your approach there, right? I mean,
Okay.
whatever the approach your is there, just solve this and paste there, right? Will I will solve there itself, okay? Because I
Okay.
think for as of now, I think the thing you are talking, we have to basically we have to think all of the cases, right? All of the cases, I mean, you are saying only for one, sorry, for 10 it will be out, right? As of
Yeah.
you are saying, right?
Yeah.
You have to think all of the cases then I mean basically even though in that case we have to think all of the case means when whether he is out in first chance, whether he is getting out in second chance, whether he is getting out in third, fourth, fifth, and after that, right? then we have to add all the probability. If you're talking about in terms of probability itself, right?
So
So
why what I'm considering is taking negation of this thing. That is, I'm not getting out in the first turn, and I'm not getting out at the second turn, and I'm not getting out at the third turn, and so on. I'm considering this case that I'm not getting out at any of the turns till I play
no, no,
card.
no. So no, we have to consider all the cases also, right? Because anyway, you can be out in a first chance also, right?
Yeah,
Then what will the probability for that?
that is going to be 1/5.
Then you can be out in second also. So it's
Okay.
not about you are getting out at the last of the after the fifth chance, right?
Hmm.
See, total you have five chances, right? You'll and your initial is the zero, correct?
Yeah.
Then it's possible you are out in the first. It's possible you are out the if you talk if you want to talk in the terms of probability itself, right? Then you have
Yeah.
to think for the probability for being out in the first chance. Then if you are going for the second case, right? Second chance, that means you are not out in first chance. Then what is the probability for out in the second chance, right?
So if I go about like using the probability tree, will it
Yeah, you can do correct. You can simply do for some five cases. Okay, probability tree will help you.
so
Mhm.
but in that case, if I consider now that there is only one branch,
Okay,
one
so I think okay. So rather than talking in air, it's good just share your approach
oh,
solve, right?
okay, okay.
So just share approach. Will I will solve there. Okay, no problem.
So can I
Hmm.
have your mail ID so that I can tag you also there?
Okay, you can find mine Prasant at the rate study. It's there. Okay.
Okay, okay, sir.
Yeah. Fine. Okay. Thanks. Anything else?
Sir, one thing.
Hmm.
Sir, for some of the practice assignment,
Hmm.
it's showing evaluation is pending. And
Evaluation is for which practice? Can you tell me?
uh, sir, for practice assignment 2.1
Okay.
and practice assignment 5, and in week 7 also practice assignment is showing evaluation is pending.
Evaluation is pending. I have submitted this before 24th March.
Yes, sir.
Need to check then with the support team. I'm not sure about this because they are doing this evaluation and all. So practice assignment 2.1 and 5, right?
Yes, sir. 2.1 week
Mhm.
5 practice assignment and week 7 practice assignment.
Fine, fine.
And
I will. Mhm.
answer for one of the mock also.
Make sure you had attempted, right? Rest to will
Yes,
check.
sir. Yes,
Okay.
sir.
Huh.
All are I attempt.
Fine, fine. No problem. We'll check. We'll check. Okay. Then thanks, Sal. Huh? Okay. Bye. Ankit,
Okay.
just paste there,
And
right? I will solve there. Okay.
sure, sir. After the maths class, I will paste there.
Fine, fine. No problem. No problem. Just whatever your approach is there, right? Just do
Oh,
that,
sure,
right?
sir.
It's otherwise you will get confused. I will get confused if you are talk. We'll talk in air itself. Okay. Huh?
Yeah. Okay.
Okay. Right. Thanks, sir.
Okay. Thank you for the session, sir.
Yeah. Thank you. Thank you. Bye.